let's get started. So in today's tutorial, what we're going to show you how to do is to kind of create this breakable kind of wall of cubes that we can kind of reset on demand or reset based on some property of the cube, like in this case when they come to a stop. And we're also going to show you how to kind of project onto this a texture, in this case, that is coming from an outside source, in this case a video that we're playing through VLC. So we'll see how to set this all up. And then the idea is that we can kind of mess around with this and kind of reset it and get some interesting effects this way by playing around with various constants and looking around in this space. Another cool thing about this space is that it's another one of these kind of abstract spaces of simple colors. So we'll also show you kind of how to achieve this look as well. So I'm going to get started. I'm going to go File, New, and we'll start fresh. So the first thing we're going to do is, again, we're going to get out of this kind of natural, real world, this planet surface space that we get started in. We don't want to kind of be in this space here. I'm just going to right-click here on the browser in this space here under Universe and create a new open space. And then I'm going to double-click on the open space to get put in here. And then the other thing I'm going to do is I'm going to turn off the exposure layer. Again, the exposure layer is what we need when we're in a real world, because we have to kind of re-expose the scene based on the brightness of the sun, and we need to be able to see the world correctly if we go into a dark space or a light space. But in this case, we're going to really control for the lighting in a very explicit way. This will allow us to get colors that we set directly as opposed to exposed colors. So I'm just going to turn off the exposure layer on this open space viewport. And then I'm going to set the haze color, which determines our background color here, to white. And the other thing I'm going to do is I'm going to create a nice big box that's going to act as our collision, our ground collision. I'm just going to go in here, I'm going to draw a box. I'm going to set it to be fixed, so it's not movable. And I'm going to center it in our space at 0. I'm actually going to stick it just below the grid here. And then I'm going to set its dimensions to be really big. Let's say 1,000 by 1,000 along the XZ axis. So, and then I'm going to lock it, Control L. So now I can't select it. So all I've just done is just created a kind of a collision surface here for our space here, so things will smash into it. And also the space has no gravity, so I'm going to set this thing's gravity as well to have like a more natural gravity. So open space, negative 9.806, more like Earth gravity. So now things will fall onto the ground. And one other thing I'm going to do is bump this down just below the grid. Okay. And let's keep playing around with the colors of this box. Maybe we'll set this, the box color is okay. Maybe, well, yeah, I think it's okay. Maybe I'll make it kind of grayish, but let's change the colors of the ambient light. Maybe the ambient light will be kind of reddish, and the directional light could be brought out a little bit brighter. Let's see what that looks like if we draw an object. Very bright. Let's maybe reduce the ambient light a little bit. The directional light. That's good for now. We can tweak that again later. Okay, so let's build our resettable box. This is our element that we're going to be able to reset. So I'm going to create a rounded box. Instead of a normal box, we'll use a rounded box instead. So I'm going to draw a rounded box here, and I'm going to make it a nice even. Give it nice even dimension, so I'm going to give it a 1 by 1 dimension so that it kind of is exactly a cube. And I'm also going to create a material for it. I'm going to create a new standard material, drag it onto it, and so we can set a different color here. I'm going to make it kind of metallically, give it a metallic look here. I'm going to give it a dark color. I'm going to set its glossiness value, reduce that. So it kind of gets this metallic metal look here. The other thing I'm going to want to do is, in its rigid body, we're going to need to do this. We're going to need to do this now, just so that when we make copies of this, it will have this property. We want to detach the rigid body's active property, because we're going to be making copies of this, but we want to make sure we can set this property independent of each copy. So, because we're going to be making shared copies of this. Shared copies mean that all the copies share the same properties, except the ones that we choose. And in this case, we want each individual item to have its own active property under its rigid body. So not this active property, but it's rigid body's active property. So we just detach that. And this will become clear why we are doing that in a second. So now let's add some script here that will allow us to reset this thing to its initial starting position. So wherever it happens to be, in this case a cube, wherever it happens to be settled in the space when we hit play, that will be the location that it's going to reset to when we either push a button or under certain circumstances. So I'm going to click on this cube. I'm going to go to the rounded box entity. I'm going to hit on init. And it's in this on init function that we're going to implement where we're going to store the object's current position so that we can then reset to it. And actually, we're going to store its current transform, not its position, but its full transform, which includes rotation as well. So that will reset it to the initial orientation. So to do this, I'm going to define for this instance, I'm going to create a local variable that's going to be per instance. So we have to define it inside the mesh entity, the table of the object, basically the instance object table. And this is going to be our initial transform. It's going to be equal to nil. And then on init, basically when we hit play, I'm going to store self.mat initial transform, which is going to equal to our self get world matrix. So it's actually a matrix that I'm storing. So the world matrix basically is a transform matrix that stores in this matrix, which is a 4x4 matrix. Stores information about the rotation of the object, its position in the space, and its scale. So we're basically saying store all that inside this variable. And the next thing we're going to do is write a reset function. This is a function that we can call whenever we want on this object that will reset it to this transform, to its initial position and rotation. So I'm going to call a function called mesh entity :reset. And in here, I'm going to animate it to its initial position. So instead of just it popping directly, we're going to have it kind of do that rewind effect. So I'm going to do a little animation here. So to do this, I'm just going to create a key clip. Using our local transform. So we're essentially creating a key clip around this transform. It's similar to when you hit a new key track, that creates it on the timeline. But this is just creating that key track internally, basically, for this transform object here. This is what we get when we call self::get local transform. I'm going to store that in the clip object, and then clip add a key. This first parameter is how long do we want it to animate to this next key value, and so I'm going to make it pretty fast, the animation, 1/10 of a second, and we're going to animate to our initial transform. Anytime we call this reset function, it's going to animate it back to its original position. So the other thing we're going to want to do, actually, let's set it up so that we can call this function, and we're going to actually on init. This is just temporary. We're going to actually create a timer here, and so when we hit play, we're going to create a timer. It's going to wait a couple of seconds, then it's going to call this reset function. So to do that, I'm just going to call get animator. I'm going to say create a timer, and it's going to call on ourself. It's going to call the reset function, and it'll call it after 2 seconds. So when we hit play, we're going to store our initial position, then we're going to create a timer. It's going to wait 2 seconds, and it's going to call this reset function. That'll reset it back to its initial position. So I'm going to hit play, throw it, 2 seconds go by, and it resets back to the beginning. Now notice what's happening here is that when it resets, it still has linear velocity from where it left off, so we have to reset that explicitly as well. And so to do that in the reset, before we do the animation, we're just going to also zero out our linear velocity. Because that, even though we're resetting its position via this, it still has the linear velocity of where it left off, and so that's why it looks like it keeps kind of, when it gets reset, it then flings again, because it's like continuing where it left off. So to reset our linear velocity, I'm just going to get a rigid body, and I'm going to set the linear velocity to vector 3, 0, 0, 0. So let's see what happens now. After 2 seconds, so there's still another component that we have to reset, and that's the angular velocity. So now we're resetting its linear velocity, so it's not flying through space when it resets, but it still has a rotational velocity, so we got to also make sure we zero that out as well. And so to do that, I'm just going to get the rigid body, and I'm going to say set the angular velocity to vector 3, 0, 0, 0. Hit play, throw it, 2 seconds later, and now it resets, and all those forces have been cleared. And so now it's only resetting once. We can also stick this temp, we can create another timer. Every time we call reset, it will basically wait another 2 seconds to reset again by sticking inside this reset statement. So let's see what happens now. So every 2 seconds now, it will reset back to there. So another thing we're going to want to do is when we create this, I'm going to show you what's going to happen here. When we create our, if we have objects in this space, let's say, we're going to also want to reset the object. While it's animating through space, we're going to want to also reset its, temporarily turn off its rigid body when it's animating the space, or else it's going to like push around objects as it's resetting, like you just saw there, which we don't want, right? So as it's flying through the space back to the initial position, it's like displacing this in a weird way. And the reason why is because its rigid body is still enabled as it's animating through the space. So we also want to disable its rigid body here. And so that's that property that we had detached before here. That's this property here. We want to set this active to false while it's animating and then reactivate it when it's done animating so that it will fly through objects without influencing them. So in the same way we created an animation clip for this, we're going to create an animation clip. We're going to first set our rigid body to active to false. This will like immediately deactivate it, and then we're going to re-enable it at the same time that we're finished doing this animation. So again, we're going to create an animation clip. Around our rigid body's active property. And then after that same amount of time, we're going to add a key at seconds 0.1 to re-enable it to true. So again, it's going to wait the same amount of time as it waits to do the animation back for its transform. After that amount of time, it's going to re-enable our rigid body so it won't influence objects while it's animating. So let's see what happens here. And now it goes straight through everything. So the next thing we're going to do is we're going to create this kind of video wall here. We're going to build it. And so to do this, we're going to hold down. We want to make shared copies of this. And the reason we want to make shared copies is so that we can then later on tweak the code of one, and then it will automatically apply to all of them. So to create a shared copy, I'm going to hold down Control and Alt. And I'm also going to hold down Shift at the same time to lock it to an axis as I'm making copies of it. So Control and Alt and Shift, and I'm just going to kind of make a bunch of copies across here. And then I'm going to repeat this process. I'm going to delete this cube here. And I'm going to select all these, Control, Alt, and Shift, and I'm going to just repeat the process going up. So when we hit play now, what's going to happen is all of these, after 2 seconds, are going to reset back to their initial positions. And then they're going to, again, another 2 seconds go by, and then they're going to reset to their initial positions. Now, another thing we should also be aware of is notice that there's some initial settling that happens when we hit play, because we copied them to locations that aren't correct, that haven't completely settled with respect to gravity. So one thing we can do is once they've settled, we can pause it, select everything, and hit Control T to commit those transforms. And this way, now when we hit play, they don't settle anymore. They're already in their position that they're going to settle to because we've committed those initial transforms. So it looks better now. There's no settling. So I'm going to go back and edit the code of the one. It doesn't matter which one. We can choose any of them since they're all shared. I'm going to eliminate this. I'm just going to remark this timer, and let's make it so that we can push a button that will call reset on all these boxes, so that we can just hit a button and it will reset so we decide when it happens. So to do this, I'm just going to go click on the open space, and then on the open space here, I'm going to hit this little menu button here, and I'm going to add a new player controller. So this is a controller that lives on our space. This essentially allows us to create global buttons that we can push that will be active when this space is rendering. I'm going to then click on the player controller. I'm going to hit this little button here, and I'm going to create a new on-off user input. I'm going to give this thing the name of reset, and I'm going to give this the letter Q in this case. It's its default binding, so that means when I hit Q, it will call this reset event. And then I'm going to implement this reset event. And so basically what I want to do inside this reset event is I want to iterate over all the objects in the space and basically call reset on them if they happen to implement that function. So let's do that right now. So I'm going to say local. I'm going to declare a local table because that's what our self colon. The self is our space. We're inside the space. I'm going to get our child nodes, and that expects a table because it fills that table with all the children. Then I'm going to iterate over that table. And for each element in the table, I'm just going to pull it out of the table to make it a little bit more legible. For each element in the table, I'm going to ask the question, does it have a reset function? So this is what this essentially does. So if we were to call node : reset, that would call the function reset. But node.reset is basically just querying the table, the object, and this the node table, which is a table that stores functions in it and objects. And it's basically just asking if it exists, basically, by doing this. So this is like a way of, so if we have other objects in the space, like this object here, we're going to get this when we iterate over the child nodes, but it doesn't have a script that has this reset function in it. And so that's what this that's what that tests for. It basically says if it has that function, then we'll call that reset function. So that's a nice way of like creating a function that will only get called, like it's like you can think of it as kind of a property of the object. It has this resetability, and when we push a button, we basically test to see does it have this resetability property, and if so, we call that function. So now when we hit the Q button, it will reset these, but these won't reset anymore, right? Since we remark the tape, we remark these timers, they won't reset anymore based on time. It's up to us to call reset when we hit Q. So now I hit Q and it resets, which is neat. So as we we'll implement another kind of reset mechanism in a second, but let's first work on this video wall. Actually, I'm going to make this square. I notice it's not square, so I'm going to create one more copy, Control-Shift-Alt, and now it's I think 7 by 7 now. Yeah. So let's create this video wall. So to do this, we're going to be using this this tool under emitters called the decal emitter. And what the decal emitter is, I'm going to just click on the center here, center of this object. The decal emitter does is it projects a material onto a surface, and it's that material. Inside that material, we can then switch out all the textures and stuff to make it kind of look however we want it. So I've clicked on the middle here, and then I'm going to go and adjust its dimensions to be a little bit bigger. And then the other thing I want to do is maybe bring it out slightly, because it will project wherever this box intersects. And so by default, the decal emitter has a very small, thin box, and I'm just going to make it, I'm going to increase its length just slightly. So because the faces of this wall intersect with this box here of the decal emitter, it will apply itself to that area onto these objects. Now the other cool thing about the decal emitter is it gets applied when we position it in space, but once we hit play, those will remain attached to the object wherever this was initially positioned when we hit play. So it sticks with the position, which is kind of nice. So that means if we make this now like this video feed, the video will kind of stay wherever it happens to be on the surface. So one way to stream in video is we can use an input texture. And so if I go here into my library and I right click and I hit new, and I'm going to create a new input 2D texture. And what an input 2D texture is basically says take an output that's coming from some outside source. Now in this case I have an outside source already streaming, and this is VLC, and it's streaming this old movie. And I'll show you how this actually works. I'll break it down. But basically, I'm going to run VLC here, and it's actually already running in the background. In VLC, I have it configured. I'll show you the default mode that it's configured by. I hit stop. I'm going to go to Tools, Preferences in VLC, and by default, if we click on Video, it's configured as automatic here. So this is just basically play it in the VLC window itself. But you can, if you go in, first you have to go and install the NewTek NDI tool. So I'm using NDI as a protocol to transfer the data across applications in this case. So if you go to NewTek NDI, if you go to the website, you can actually download these NDI tools. They're free. And when you do, it will install a, I think VLC is part of this. Yeah, here it is, the VLC plugin. It installs a plugin in VLC that you can then go under Tools, Preferences, Video, and then under Output you could set it to automatic. You set it to NewTek NDI Video Output. And so when you hit Save and then we hit Play, what it starts doing is it starts feeding it across NDI. And then Simmetri is set to listen in on that. And you can actually change that by going, when you create an input texture, you can set the binding if you have multiple streams, let's say, by going under Edit Preferences, Input Textures, and then under Set. And you can choose all the different bindings here that we can kind of choose. So if you had multiple applications that were streaming out data, like Resolume, for instance, would appear here. And this also supports Spout and as another kind of transfer mechanism. So anyways, right now we're having it send this video texture in here. And then what I'm going to do is on the decal emitter, I'm going to go to its material, and I'm going to set the diffuse texture to be this texture here, this input texture. And so there it comes in. and it's being projected on. And also this default decal material also has a texture map for its opacity, which is that splat texture. I'm going to set that to none, so it becomes a square. And then you'll notice that the decal is actually rotated. So I'm just going to hold down Shift and Alt and rotate the decal so that it faces forward. So there we go. Now we have this video streaming in on this wall here. And again, we hit play, we can kind of modify it, and then hit Q to return it. And then each individual kind of square kind of maintains that section of the video, which is kind of nice. And then hit Q and I reset it. So I'm just going to, I think in the original preview thing I had some text in the background. We can make this kind of a stylized space here. I'm going to create the text here. I'm going to extrude it out a little bit. I'll make it, give it a much bigger size, give it a different color, kind of like orange. Maybe a different font for this. I set its font to set it to Eris. And then we can give it a different, we can have it say video wall or something. Kind of this abstract space. And this is where now I want to kind of tweak, make this a little bit bigger. We can tweak the look of this space a little bit before we kind of try some other stuff here. So I'm going to maybe change our ambient light color, make it a little white here. I'm going to add a new, to our open space viewport, I'm going to add an image filter layer. I'm going to add a brightness filter. So we're going to basically create here a brightness pass so that we can then apply bloom. Because I turned off the exposure layer, that normally adds our kind of bloom effects, this like over brightness kind of glow. But since we turned that off, we have to kind of do it ourselves. And so to do that, I'm going to create a new image filter group. I'm going to create a bright pass value. I'm going to then set it the bright pass value. I'm going to give this a lower threshold. So this basically says anything that we can kind of see is going to become blurred and then applied as bloom. And so the darker we make it, the less bloom we'll have. So if I make it very low, this value, and you'll see in a second what this means. So bright pass, and I'm going to add Gaussian blur horizontal, Gaussian blur vertical. I'm going to add another Gaussian blur horizontal, another Gaussian blur vertical. And then on the parent image filter group, I'm going to set the downsampling to downsample 4x. So now we have this blurry image. That is only the bits that we allowed through via this threshold of the bright pass filter. And then the last thing we want to do on the image filter group is make it additive. So now that adds it on top of the image. And so now it's kind of bright because everything's kind of is over kind of saturating. And so we can adjust this value, make this a little darker here. We get less bloom now. And I'm going to keep making some adjustments to this. Maybe to our directional light, make this brighter, kind of brightens that out. We can turn off our ambient. It's still kind of bright. Turn off the grid here. Maybe make a different color for this. Turn off this ambient light bleed was turned all the way down. That's super bright. Now I kind of get this reddish ambient look here, which I like seeing some of the black and white coming through of that. Maybe I'll create a new material for this thing here. This always comes down to just tweaking, spending a lot of time with this until you kind of get the right look here. Maybe we'll fade out this a little bit. Maybe I'll make it a little bit less bright passy. Reduce the amount of haze. Maybe on the ground here, just tweaking here. It's a little bit closer to the background. Yeah, it's a little bit oversaturated. Not quite the look I was going for here. There's always some parameter here that if you miss it. Well, that's, you know, kind of lose the shadows now. Well, let me reduce this maybe a little bit. All right, well, that's good for now. So let's keep playing around with, maybe we can change this wall a little bit so that instead of us pushing a button to reset it, we can get it to reset based on some property. So maybe when these boxes come to a stop, they could reset themselves automatically. So to do this, I'm just going to go back into the box code here, and we're going to write a onTick function. So this is a function that's called every frame. And inside here, what we're going to do is we're basically going to measure the object's speed, and if it goes below some threshold, i.e. it's kind of coming to a rest, then we'll call a reset. So that we have to finagle, we have to be kind of aware of, we don't want it to, like, as it's resetting, to keep calling this function and stuff. So one way to filter for this is just to look at our getRigidBody.active property, and only if it's true do we actually perform this kind of test. So that in the middle of our animation, it's going to be false. So while it's animating, it's going to be false. So then it won't call this code while it's animating back to its initial position. And if it is, the idea is if our if our speed basically if it ends up dropping below some value, this is where we want to call self.reset basically. But again, if we do this, it's going to get in a weird, it's going to keep resetting, and it's going to, like, as soon as we hit play, it's going to reset because it's going to be less than 1, and it's going to be a little strange. So what we really need to do is just kind of have a variable that's going to control when we call this basically. And so we only call this when a variable is set basically, so we can control for how it resets, and then so that we don't kind of step on ourselves. So I'm going to set inside the mesh entity, I'm going to create a variable called resettable, initialize that to false. And so only if we are resettable do we call this reset function. And then we're going to reset our resettable property to false here. Else, this is like what we want to do is we want to now measure what is our measurement for enabling this path, basically. So we want to basically set resettable to true when we want to accept, when we want to start testing for its length to be less than 1 to then reset it. So actually I'm going to flip this order around. If it's resettable and our linear velocity drops below a certain number, then we reset it. Else, if our speed maybe goes above a threshold, does that enable this code path to then reset it? So if our speed maybe goes above 2, then we're going to set self-resettable to true. So in the beginning, they're all kind of settled and they're not moving, and resettable is false. So it's not greater than 2, the speed, so it won't do anything here. Then it's going to, when we throw it, they're going to go greater than 2, so it's going to enable this resetting path here, such that when it finally drops below 1, it will then reset itself, set this back to false, and then it will wait until their speed is above this to reset it. So this just ensures that we control for the exact moment that it resets. So let's see what happens when we hit play. I'm going to stop. I didn't commit these transforms. So one thing to be aware of is if you move things while playing, you have to explicitly tell Simmetri that you want to store those positions, or else when we hit stop, it resets it to the initial position. So you can do that by hitting Control-T at playtime. Okay, so I'm going to hit play here. So let's move these things. So these objects, as their speed slows down now, they're going to reset to their initial position. Which in this case, some of those things are going to be floating in the middle of the air, which means that then they're going to have to they're going to start to fall from that location. And so that's what we're seeing here, which is kind of an interesting thing. So again, when they reset to those initial positions, since they're hovering in many cases, if the objects below it haven't reset yet, then they fall from there, and then we get this kind of fun, this kind of strange, kind of self-assembling, kind of weird wall thing that kind of continually kind of readjusts itself. The other fun stuff to play with here is you can keep tweaking all these values. For instance, maybe we want it to animate more slowly to the initial start position. So now it'll take longer to animate to the initial position when I hit a button or when it resets itself. So you can see they're kind of falling into each other because it hasn't finished re-enabling the rigid body. So the other ones that do finish first fall through the other ones. And that one is just going to keep attempting, and now it's going to go. There we go. So I'm going to keep editing the code here and playing around with different constants here. So maybe we want it to be less sensitive. So in other words, it has to really come to a stop here now before it resets, and maybe we'll make it fast again. So now that it'll only reset when they really come to a stop. And the other thing I can do here, which is always fun, I'm going to lock this in the background, is we can move all of this up. And so now they're going to attempt to reset to that top position every time. So we have this cascade effect. Unless we hit Q, then they all kind of go up there, and then they all fall from there. So there's a lot you can do with this kind of effect, and it's kind of fun. You can kind of place things all sorts in the space. You can build structures that then kind of reset themselves, and by being kind of creative with the timing of the resetting and when it happens and how it happens, you can kind of achieve all sorts of interesting results that way. So I hope this was interesting. Thank you for kind of watching this tutorial, and we'll catch you next time.